Hey folks, Matthew Lanigan here with BayWa RE. Just going to give folks two more minutes to log in. I see people still logging in, and we'll be back with you here very shortly to kick things off. Thanks. Hi folks, Matthew Lanigan here again with BayWa RE. I'm the Chief Commercial Officer here for BayWa Canada. Really appreciate you all taking some time today to be with us and SMA to learn some more about their commercial inverters. SMA is a fantastic partner of ours. We deal with them in just about all our 29 countries around the world. Personally, I've had experience with the product over the most of my 20-year career here in solar, and just a really fabulous partner. Just a couple of housekeeping notes before. This will be recorded. It'll be put up on our YouTube channel. If you haven't signed up for our YouTube channel, I would encourage you to do so. Our past webinars can be found on there as well. Also, the recording will go out in our monthly newsletter starting in the first week of September as well. If you do have questions, please put them into the chat box in the bottom right corner. We will have breaks and we'll answer your questions during the breaks. Continuing education is very important to BayWa, so we're really happy that you could spend some time with us to do that. And just before I introduce Michael, I just want to test the chat box. If anyone could just say you're out there, say hello, just make sure things are working properly. Great. Thank you, Charles. Okay, so without further ado, I'd like to introduce Michael Mahon with SMA Technical Trainer, Solar Academy.
Awesome. Thank you very much, Matthew. Let me see if I can share my screen. And for everyone listening, I do apologize if we hear any background noise. Having some work done at the house, as luck would have it. But thank you for the opportunity to discuss both our CORE1 commercial inverter, and I will briefly discuss our PEAK3 large-scale distributed ground mount string inverter towards the end. But I want to start with probably our more popular inverter, the CORE1. So I want to, and this is me, sorry, I'm not going to turn my camera on. We'll be looking at a work zone. I have been a Solar Academy trainer for a little while, and I'm right now is a great time to talk about SMA's portfolio. Very, very clean. Our CORE1 is our three-phase commercial inverter, and our PEAK3 is a kind of off-of-the-shelf utility scale inverter. So they're both very interesting and I think enthusiastically adopted products. So I want to spend a little bit of time on the overview of the CORE1. I want to talk about the shade fix optimization built into the CORE1, and a little bit about rapid shutdown. And I do apologize when I present those slides. The rapid shutdown code references are going to be from the NEC, the National Electric Code for the US. I have a very limited understanding of exactly what is being enforced in Canada right now. Hopefully I will get it right, but I will plead ignorance in those sections so that you can figure out what solutions that pair with the CORE1 or the UL 3741 listing, what makes sense for the jurisdictions you would install in. And I want to talk about two little software unlocked features for the CORE1. Then we'll take some questions on the CORE1 and switch over to the PEAK3. So if you haven't seen a CORE1, this is what the device looks like. When we launched this back in, I believe, 2016, we kind of referred to it as the dorm fridge. We wanted a compact device. This is primarily focused on commercial rooftop, but can be used in lots of other areas. But we want a device that could be freestanding on a commercial rooftop and not be a large shade object, to have it be able to be placed within the array closer to the modules that are powering it without requiring a support structure be built or worrying about parapet wall space. And you can see the DC disconnect handle in this picture. We also tried to include in the body of each CORE1 all of what we expected any installer might need for balance of system components for the inverter. So we'll talk about that in a bit, but I think a very good job was done in designing this to provide a very easy to install and a very quick install for customers using the CORE1. As I mentioned, this was designed for commercial rooftop, but has been used widely in carport applications, large ground mount as well. So while the focus was commercial rooftop, wide applicability for this device. As it is a commercial inverter, it is rated up to 1,000 volts DC. The CORE1 US-41 line, when we launched this product, it was only a 50 kilowatt product. And if you are familiar with SMA offerings outside of areas where UL listing is important, IEC listing, say in Europe, it is only a 50 kilowatt unit. When we revved from the 40 launch number to the 41, we introduced the 33 kilowatt and the 62.5 kilowatt units as well. So those are UL listed, all three power classes. The products look identical. So for all the power classes, the spec sheets, the number of inputs, all of that remains identical across the line. That is just the AC power limit that is different between the different units. The architecture of the inverter, as this was primarily aimed for commercial rooftop, was around design flexibility to allow designers to place PV modules across a commercial rooftop and attempt to fill all addressable space with PV modules while working around any obstacles on the roof, such as stairwell access, skylights, HVAC units, and maybe code mandated walkways have to be broken up, have to break up the array every so often. We still wanted all addressable space to be able to be filled with PV and connected to the CORE1. Along those lines, the operating window and DC voltage for each CORE1 is 150 volts up to 1,000 volts DC. So a very wide voltage operating range. So providing design flexibility on the front side. And when we talk about shade fix, having that wide DC operating window maximizes the value of the shade fix algorithm as well. In addition to the wide voltage range, the DC inputs of the inverter are broken up into 6 independent tracking channels. So each CORE1 US-41, it's as if you're getting 6 inverters in each box. Each tracking channel is managed independently by the inverter. So that means you can have different operating voltage points for each 6. So you can have different string lengths, you can have different orientations for those inputs. And since there are only 2 string inputs coming into each independent tracking channel, no overcurrent protection is needed on the input side. So there is no space for fusing here behind the DC disconnect lid. There is no need for that overcurrent protection unless you have a module with a low enough current that you might be trying to put 3 strings into one input, and then you could probably use a wiring harness with inline fuses. The DC connectors for the inverter are bulkhead connectors there on the body, so you can see the bulkhead connectors in this image. These connectors are Amphenol UTX connectors, and in the box with every CORE1, we include the Amphenol UTX mating connectors and ferrules to crimp on your inverter ends of your home run wires. So you have Amphenol UTX mating to Amphenol UTX there at the body of the inverter. And if you don't use some of the inputs, we have sealing caps for those unused inputs. So flexibility in terms of string length, design, module orientation, module power class. We're seeing, I think, great interest on bifacial modules that are getting to higher power and also high current. So when we show the spec sheet, quite often we're finding people can get a good DC to AC ratio on the CORE1 with those newer high current modules using one string of modules per input. And the nice thing on the CORE1 is you can drive a tracking channel input fully through a single positive and negative connector for that input, even though two are provided on the inverter. And I'll try to reemphasize that a little bit, make it a little more clear on the spec sheet slide. The CORE1 requires connection to a 277/480 grounded Y AC service. When we talk about the PEAK3, there is an option for that inverter to connect to a 600 volt three-phase AC service, but that is not an option for the CORE1. All models of the CORE1 for the US have integrated both a load break rated DC disconnect, and on the opposite side, there is an AC disconnect as well. So there is no need for series fusing. We're including the DC disconnect and the AC disconnect in the body of the inverter. So we're aiming to have a very easy to install system with potentially all required balance of system components built right into the body of the inverter. So I like that very much, makes discussion of the CORE1 very, very easy. As I mentioned, we'll talk a little bit about rapid shutdown for the CORE1, and there's a fairly, certainly for the US, a fairly exciting new listing for the CORE1 that relates to rapid shutdown. So we'll discuss that. I don't know it's as important in Canada, but we'll talk about it. And the new features that I had mentioned on the intro slide, I think probably not the most current, but the prior release of firmware for the CORE1 US-41 line unlocked two features in these inverters. One allows you, through the user interface of the inverter, to have the inverter perform an IV curve trace sequentially on each of its 6 inputs. So that's a very nice built-in feature that allows, I think, for good checking at a regular interval along a preventive maintenance cycle, perhaps, to do an IV curve trace on the array attached to the inverter and document that. And use that as a first step in more thorough troubleshooting if something appears incorrect in that IV curve trace. So we'll talk about that a little bit. And then also there is an update related to Afci functionality. And again, I will plead a little bit of ignorance on Canadian code on this. What that update on the Afci functionality allows is you can leave the inverter where if it detects an arc fault, it requires a manual resetting of the inverter to go back into service. But the new firmware also allows an option where you can allow the inverter, if the arc that it detects is under a certain incident energy and is extinguished within a certain time frame, it will allow the inverter to automatically restart. So I don't know if that is per se allowed by code in Canada, but that is a feature now that the firmware unlocks in these units, and I'll talk about it in a little bit of detail so that you understand how it operates and if it is of use to you, how to turn it on. I don't want to spend too much time on the inverter, but you have some dimensions here. You see the rating. The operating temperature I'll talk about briefly because I think certainly in areas of Canada, the low end of the operating temperature is of interest to folks. The operating temperature goes down to -25 C. The safe exposure temperature for the CORE1 goes down to -40 C. But if the inverter wakes up between -40 and -25, it will wait to go into operation until it achieves the -25 C temperature. And there's a very specific error code you'll see, waiting for minimum operating temperature until that -25 C level is hit. Before we show an interesting installation picture, I do want to point out and I don't know if this is where the inverter's line name came from, but you see the perforations in the top cover of the inverter. The central core of this inverter is actually an airflow chimney. So there are heat sink fins that protrude into that center area, and there is natural convection up through the inverter as a first stage of cooling. And then you may be able to see the fins here, the kind of ribs covering the fan tray that is at the bottom center of the inverter. If the inverter's internal temperature hits a certain level, these fans will come on, and then you're cooling by forced convection. And those fans are speed control based on the temperature of the inverter. So we definitely want folks to leave that airflow path clear. Generally though, if it's very, very cold, some people ask, well, what if snow builds up on the top of the inverter? Generally in that condition, you're worried about the low end of the temperature range versus the high end. But generally we do want that airflow path to remain clear. Even if it's hot air being blown over those heatsink fins, the inverter will manage itself thermally. But generally if there's a bunch of snow sitting on top of the inverter, it's not a question of is it running too hot, but potentially too cold. This picture is a bit out of date. This is several years old, but I believe this is one of the first installs of the CORE1 in Canada. And it was fairly far north. And so they decided that the operating only at minus 25C was going to be a concern for this install location. So the inverters were installed indoors in kind of a thermal protection shed, and it was definitely for the cold end of the operating range, not the hot end. So definitely based on the install location, that operation at minus 25C can adjust your design considerations, but certainly usable in those colder climates. I'm sorry, this is a very boring slide, just data sheet information. We're showing the top part of the data sheet for the 33 kilowatt, the 50 kilowatt, and the 62.5 kilowatt models of the CORE1 line. The two values circled in green on this slide show the maximum operating voltage for any model of the CORE1. That is 1,000 volts DC, so that would be the maximum temperature voltage that any of the inputs of any of the models of the CORE1 can be exposed to at the coldest temperature for operation. You have to stay under 1,000 volts DC for open circuit voltage. And the second value is circled is a short circuit current limit. And the data sheet shows it as per maximum power point tracking channel and per string input. And that short circuit current limit is the same for each channel, which has 2 string inputs, as well as each string input on the inverter. So I had alluded to this earlier. Each tracking channel can be driven fully through a single positive and negative input pair for the inverter's body. So potentially if you're using a high current module, bifacial module, you expect a lot of backside gain. Having one string of modules come into each tracking channel might be the correct design choice. Or if you have an array that is far removed from the inverter location, having 2 strings using a Y-branch connector to combine the 2 positives and 2 negatives at the array into a single positive and negative, and bringing that back to each tracking channel might save on conductor costs. So that ability to drive each tracking channel fully through a single positive and negative input has been used by a lot of customers to good effect. If these values for the open circuit voltage and the short circuit current are always being respected, the first row of the data sheet shows the maximum array power, that is the maximum STC rating that SMA will allow you to connect to each model without any consultation from us. So if you do the math, it's a little easier for the 50 kilowatt unit. It's a 1.5 DC to AC ratio, or 150%. You may hear this referred to also as inverter loading ratio. There are a few acronyms for it across the industry. So that's a fairly good ratio, but we do get questions from folks who want to exceed that. And I do have a slide a little later. It references both the CORE1 and the PEAK3. If you do wish to exceed that data sheet DC to AC ratio, SMA is going to ask you to construct the site-specific design in our design tool. So the actual modules you're planning to use, how they're mounted, wired up to the CORE1. When the simulation is done, not only will the design tool show an expected kilowatt hour or megawatt hour per year yield, it will also produce a metric called full load hours. If that full load hours stays under 2,400, you can safely exceed the datasheet DC to AC ratio without voiding your warranty. You always have to respect the maximum open circuit voltage and short circuit current limits. And again, just to be clear, if you're satisfying those 2 limits, you can go up to this 150% ratio without any further conversations with SMA. It's only if you wish to exceed that ratio that you need to do the Sunny design calculation. This is fairly boring slide kind of showing what's in the box with each CORE1, but I do want to reemphasize that we're giving you the mating Amphenol UTX connectors and ferrules to crimp on the inverter ends of your home run so that they can mate with the bulkhead inverter connectors that are also Amphenol UTX. And if you're not bringing a home run cable to an input pair, we have sealing caps for them. So each and every positive and negative on that bulkhead should receive something at installation, either a home run cable made up with the included Amphenol UTX connectors and ferrules, or a sealing cap. And we have moving handles, commercial rooftop feet included with each unit. But if you're not going to use those commercial rooftop feet, each inverter ships on its side on its own little pallet. And when you take the box off of it, you have immediate access to the bottom of the inverter where those commercial rooftop feet would mount, or if you were maybe attaching the inverter to the actual racking structure, maybe it's a very high wind area and you need to lock down the inverter in a little more secure manner, you have immediate access to those threaded screw holes on the inverter body at the bottom immediately out of the box. And this picture shows a little better the construction of the fan tray. So there are 3 fans in that tray. There's a handle to release it and drop it for inspection for PM check. So pretty straightforward setup. We're aiming to have it where it's very easy to get the inverter close to a final location, unbox it, use the moving handles to put it in final location, lock it down, and then wire it up. So again, we're aiming for a very easy to install unit. The bulkhead connectors that we provide, I want to make sure that folks are aware, the connectors are for 10 or 12 gauge conductors. If you are doing a paralleling of the positive and negatives at the array and bringing back a single positive and negative and upsizing those conductors, you can source from Amphenol connectors for bigger gauge wire, but what we're including in the box with the inverters are for 10 or 12 gauge wire. And below that DC input connection, there's a small equipment ground bus bar for the DC side. And again, just trying to emphasize, make sure everyone's aware that the 6 tracking channels for each unit can be connected with strings of different length, different orientation. They could even be different module type. If you need to clean out the warehouse and you don't have enough of the same type module to connect to the inverter, and no one's going to see that roof and say, why do the modules all look different? It is certainly electrically possible. Again, you have a very wide voltage range for each of the inputs, and the inverter manages each one independently. With the flexibility, though, there is one design constraint so that we don't need that series fusing. You cannot parallel across the 6 tracking channel inputs. So a fully loaded CORE1 at a minimum is going to have 6 positive and negative home runs coming back to the inverter. I want to switch gears a little bit and talk about shade fix briefly. This is the energy optimization shade mitigating technology that is built into both our CORE1, and the image above that is our Sunny Boy residential single phase inverter. Both of these inverter lines have this shade fix optimization. And I don't want to spend too much time on what it is, but what it provides is the ability. You may have seen on industry websites, this screen capture I took is probably 3 years old now, but certainly I think misleading at the time, and you may see statements like this, that a string inverter is capable of only working at the point of the weakest module in the string. And the whole point of being of shade fix is to prevent that statement from being true. It is an optimization algorithm that is based in the inverter that prevents the inverter from being stuck at that quote unquote point of the weakest module should there be partial shade on the array. And again, each of the 6 tracking channels for the CORE1 is going to have this shade fix optimization testing the best point. So the array is broken up according to those tracking channels for purposes of the CORE1 applying this shade fix algorithm. And this graphic is coming from a white paper on shade fix that is on the SMA-America.com website. I think this is a really good piece of information if you're discussing with a potential system owner what shade fix is providing. The takeaway from this series of graphics is, in comparison to a standard DC optimizer system, an SMA shade fix optimized inverter is capable of providing higher yield, that is AC kilowatt hours out of the inverter, the only metric that pays off the system and makes the system owner money. The shade fix systems are capable of providing higher yield in the vast majority of shade scenarios compared to the standard DC optimizer scenario. And generally the follow-up question to that is, well, how? And the short answer, which I won't elaborate in this presentation on anymore, is that the standard DC optimizer architecture often glosses over the fact that those optimizers consume DC watts all of the time the system is in operation, whether or not they're providing a shading or mismatch benefit. So that continuous DC power loss results in lower AC kilowatt hours out of the inverter for the vast majority of shade scenarios, compared to the shade fix optimized system where an inverter-based periodic sweep is occurring. Only in the most severe shade scenarios is that continuous DC optimizer power draw finally outweighed by the benefit they provide. And like I said, if you like more information about this, I am very happy to talk about this in technical detail at length, but I don't want to sidetrack the discussion of the CORE1 with that right here. So feel free to follow up with me if you want more information on shade fix. But again, that's kind of the argument that the energy optimization of the CORE1 can beat or at least be equal to the standard DC optimizer architectures in the vast majority of shade scenarios. That works into a rapid shutdown discussion in the US by the fact that we do often require in the United States for rapid shutdown code compliance, some devices touching each and every module. But we at SMA advocate the use of simple code compliance devices that are not doing any power conditioning. So devices that are fairly simple or higher reliability and are also not operating all the time to avoid that continuous DC loss. Now in the US, 2017 and 2020 code books that are adopted at various times by different states in the United States are requiring this, in essence, module level shutdown. And that has been kind of the rule anytime a state adopts code from 2017 on. My, again, very limited understanding of Canadian code is that there is not a inside of the array voltage requirement like there is in the more recent code editions in the US. So that provides a benefit that we're finally getting back in the United States based on a certain rapid shutdown listing for the CORE1. So if customers need that module level shutdown, we have devices that are simple code compliance devices that listen to a power line communication generated by a board pre-installed in the CORE1 from the factory. So there's no additional communications channel needed to utilize this way to comply with module level rapid shutdown, just the CORE1 US-41 and an SMA approved receiver device at the modules. So we have several options for pairing with the CORE1.
And Michael, we do carry the AP Smart units.
Oh,
so
awesome.
Yeah.
And so this, you can see that the top device is a device called the JMS-F. The two below that are produced by AP Smart. They're single module, single receiver device, as well as their dual module, single receiver device that comes in a 15 amp or 20 amp variant. So again, modules getting up to higher current, this 20 amp can be very attractive, but we're providing lots of options that for the array, these receivers at the array that can be paired with our CORE1. If you are using these devices, we do ask that you only use devices that have gone through the SMA approval as well as the SunSpec certification. Those that have a green check mark in this matrix. The latest and greatest document can always be found at SMA's website. Don't rely on this slide. A year from now, we probably will have added new options. So feel free to check the website, but please, the green check mark means that SMA has gone through compatibility testing with these devices so that the operation of rapid shutdown is not in any way impacting the other safety features or operational features of the CORE1. So that SMA approval is like full wrap testing. SunSpec covers all the rapid shutdown functionality, and the SMA approval testing covers everything else. Again, if you are using the JMS or the AP Smart devices, those devices attached to the modules and then turning on the transmitter board in the CORE1 is all that is needed to then allow anytime AC power is removed from the inverter, that is the signal for that transmitter board to stop generating the power line communication signal going to the array. The devices at the array, that's their only job, is to listen for that signal. They're not doing any power conversion at all. When that signal goes away, very quickly they will begin to isolate their modules from the string they are part of. They don't break the string, but the device output leads will have a very low voltage, somewhere in the order of 1 volt DC, when that signal goes away. And so that meets the inside of the array voltage requirements for the latest National Electric Code. As I mentioned, we have kind of an exciting update on the CORE1. There is a listing process from UL, the UL 3741 certification, that is related to rapid shutdown as it's specified in the National Electric Code. The inside of the array requirement most commonly is met by voltage reduction. That is very clear to understand. There are devices that can comply with that in a very straightforward manner, but that is not the only way that installers can comply. There is the UL 3741 listing. So this is a testing procedure that verifies that when rapid shutdown is initiated, that shock hazards to first responders, that's firefighters, is within acceptable limits in the array. So it doesn't require a data sheet value that may or may not be tested under conditions for which it is supposed to provide protection. The 3741 testing actually tests under conditions for which this system is supposed to provide firefighter protection. And the CORE1 paired with 2 different commercial rooftop, and these are ballast mount systems. The Solega, I think it's Fast Rack 510, and the Iron Ridge BX systems. Both of those systems, in conjunction with the CORE1, have successfully achieved this UL 3741 listing. So what that means is, if the inverter can be placed within the array boundary, and the most recent NEC code says that is 1 foot from the array and any racking and support structures, so that would include all the ballast tubs for the Solega or Iron Ridge systems, then the inverter being within that perimeter, loss of AC power will de-energize the AC conductors up to the inverter very, very quickly. So that will cover all of the conductors outside of the array boundary, which are still required to go down to very low voltage. And then the UL 3741 listing, without the need of any module level power electronics, will satisfy the inside of the array boundary, again, as 2017 or 2020 NEC specifies. So certainly for commercial rooftop systems in the US, where we generally had to fall back on this voltage reduction, this is a very exciting, I think, additional option. Again, the CORE1 can be used with those AP Smart devices if that is desired. If the CORE1 can be placed close to this Solega or Iron Ridge racking system, and again, per code, the array includes all the support structures. So that includes all of these ballast tubs here. Then that's an additional way to comply with the latest rapid shutdown requirements. But if there's not a need, or the designers do not see a need for DC optimizers at each system, and the module level devices are there simply for code compliance, maybe it makes sense to go via this UL 3741 listing to achieve all of the requirements of 2017 or 2020 NEC. So I think this is an exciting addition to the CORE1. Again, this is both the Solega and the Iron Ridge systems are these ballast systems. So generally this would be commercial flat roof only, but I think very, very exciting advancement for the CORE1 for code compliance. And again, the nice thing is, if you are using this method for code compliance, those AP Smart devices are just code compliance devices as well. All of the energy optimization of the system, no matter how you're complying with rapid shutdown, is still available in the CORE1. So this is a great feature for potentially carport systems as well, which quite often don't require rapid shutdown. You still have the shade fix operating on each of the tracking channels in the CORE1, no matter what devices may be out at the array with the modules. So again, a lot of design flexibility, a lot of things to think about, but I like the additional options for compliance with the CORE1. So we're trying to improve the product in all ways, even though it has been out for a while. Along those same lines, I had mentioned 2 features that were unlocked by a fairly recent version of firmware for the CORE1. That is related to the IV curve tracing as well as the AFCI behavior. So the version of firmware that is required is 3.12.21, and this is firmware only for the US-41 units. But with this firmware installed, you have the ability now to log into the user interface of the CORE1 and ask the inverter to perform an IV curve trace on all of its 6 input tracking channels. You do this while the inverter is in operation. You start this request, and then the inverter sequentially takes each of the 6 tracking channels out of operation, performs that IV curve trace from VOC down to short circuit current, puts that channel back into operation, moves to the next one, does the same curve trace, and when the tracking is done, presents that in the user interface. This takes roughly 20 seconds per tracking channel, so about 2 minutes to perform that IV curve trace. And what it looks like is shown here on this slide. So with the latest firmware, with the 3.12.21 and higher firmware, you have this diagnosis screen on the user interface of the CORE1. So you have this new diagnosis tab. You can come into this and click Start New Measurement. When you do that, any historical data here is discarded. So you have the ability at any time to export the current values as a PDF, so just a replication of the curves with some data and the date the scans occurred, or the data as a CSV file. So you can actually export that data, plot it elsewhere. Just remember that this is not, historical curves are not stored. So when you click Start New Measurement, anything that was logged is thrown away. So please offload the data once the curves are complete. And this is something you should see. If the strings coming into the CORE1 are all roughly the same, you should see very similar curves. This functionality is provided as an easy way for someone responsible for the maintenance of the system to check periodically the health of the array attached to the inverter. This is not the level of accuracy that would allow you to process a module warranty claim, but this could be a first step. If you see all the strings coming into the CORE1 are the same length, so you expect to see the same VOC, and you see something 30 volts or 60 volts different on one tracking channel, then that's a signal to say, okay, maybe we do actually need to go shut down the inverter. We know it's tracking channel C. Let's do some actual, high resolution curve traces with a dedicated instrument on the strings coming into tracking channel C and proceed from there. But this is, I think, a really valuable, new kind of just diagnostic tool that's built into the firmware of the CORE1 US-41. And I want to mention, I skipped over the slide, I want to go back to it. If the rapid shutdown transmitter board, that SunSpec transmitter board in the CORE1 has been turned on, you're using the AP Smart devices there at the array for rapid shutdown, the inverter, when you trigger the IV curve trace, it's smart enough to know that if it drives everything all the way down to 0 volts, eventually you're going to start turning off the rapid shutdown devices. And then the data you're getting is not representative of the modules behind them. So if that transmitter board is turned on, when you click Start New Measurement, the curves will go from VOC to about 230 volts DC. So this part of the curve will not be present because you'd have misleading data down in the low voltage side. So this IV curve tracing works with or without the SunSpec receivers at the array and does not require any disconnection of the devices from the modules to perform the IV curve tracing. So yet another good benefit, I think, of this feature. So pretty exciting. I think we've gotten great feedback on this. The one request for improvement we've gotten is currently this has to be triggered in the user interface of the inverter. We don't have the ability right now to trigger this remotely through our NXOS Sunny Portal monitoring site, but it's been a very common request, so I do believe that's a high priority action item. So hopefully we can do that remote triggering of this tracing soon. But right now it requires you being logged into the user interface of the inverter. And please just remember to export the data once you've finished the curve trace. The other functionality that the recent firmware unlocks in the CORE1 is again related to how the system handles arc fault detection. It used to be when in the National Electric Code, AFCI detection was required, code specifically called out that a manual restart of the system was required anytime an arc was detected. That can be cumbersome if the site is fairly remote. 2017 code in the United States allowed for the ability to restart automatically from an arc event, again, if the incident energy of the arc was under a certain threshold and the extinguishing time was short enough. Code then explicitly allowed it. And with the new UL 1699B Edition 1 full standard, there was testing methodology to test that, to verify the limits and allow for that automatic restart. So the 3.12.21 firmware allows that. So there's an additional setting for parameters in the inverter related to AFCI, more than just off or on. And if this is the default, the yes on is the default from the factory, even with units with this firmware. So units from the factory with higher firmware and those in the field that have received automatic firmware updates, you will still have yes chosen for the AFCI behavior, which requires a manual restart. But now with this firmware or higher, you have an additional choice for this parameter value, yes, without permanent operator inhibition. And that means yes, allowing for automatic restarts if the incident energy is low enough, the extinguishing time is fast enough. There will still be a disruption in the inverter production, but if you have chosen this without permanent operator inhibition and the arc was, again, low enough energy, extinguished fast enough, you can have the inverter go back into production. A lot of feedback we've gotten from customers, we have been including an arc fault detection in our inverters for many years now, I think 11 years now. We have improved our algorithms quite a bit. Please, anyone listening who deals with our inverters, if you see continuous arc errors on the inverter, please, please, please treat those as real. It may be very hard to visually identify where in the array the arc is occurring, but if you are seeing multiple issues with an inverter, please treat them as real. We feel that we have increased the reliability of our AFCI detection quite a bit. So if you see, one error every 3 months in the morning when there may be condensation somewhere, yeah, that's probably fine to, treat as a transient. But please treat these errors as very serious, and if they are occurring with frequency, any real frequency, please, please, please treat them as real. Okay, great stop on point for any other questions on the CORE1 before we jump over into the PEAK3?
Yeah, we've got a couple here.
Yeah.
So does the modeling software PVSys properly model the effects of shade fix?
I don't know that I can speak to PVSys. There have definitely been improvements in the SMA design tool to model shade. We can include nearby shade objects and their impacts on arrays, and you can explicitly, you are notified kind of what shade fix is doing. The latest update to our modeling tool includes kind of string layout. So you could actually see the impacts of changing up how the strings are wired to the inverter. But as far as PVSys, if the person asking this wants to follow up with me, I can forward the question on to our applications engineering team to see if they have knowledge of how PVSys is handling it. But I apologize, I really don't know the answer to that question.
Sure. We have IV curve tracing data. Is the data accessible via an API that would allow periodic automated testing and data reporting?
So my understanding right now is no. Again, to trigger the IV curve trace, you need to be appearing as if you're on the same local area network as the inverter to access its user interface. And then if you're doing that, potentially you could have the ability to export as CSV. I don't know how to automate that though, and then have that data pulled off. So my thought is no, there is no way to completely automate that cycle. But again, that is a great request. And if you want to forward that via email to me, again, I can send that to the appropriate people internally. We are endeavoring to have the ability to trigger the tracing remotely. And so I'm not sure what level of detail has been considered for extraction or display of that information.
Okay. Are the strings fused internally in the CORE1 or PEAK3 on top of the DC disconnect, or they're just a disconnect for protection?
Correct. So the CORE1 has a DC disconnect, and that is simply a disconnecting means. As stated in terms of the architecture, there are 2 string inputs per independent tracking channel on each CORE1 input. So if you're having 2 strings come to the inverter body, let's say there's a fault on one, and that faulted string gets backfed with the current of the non-faulted string, but that's simply 1 string's worth of current. So again, code generally does not require overcurrent protection for that scenario. only if you had, and this is not common, but much older modules that had low current and you wanted to combine 3 strings into one positive and negative input on the CORE1, then you would need to provide external to the CORE1 that overcurrent protection. The PEAK3 does not include a DC disconnect, and there is not input overcurrent protection.
Okay, I think I can answer this one. With the unit being SunSpec compliant, can you just use the AP module level units for RDS, or would you require AP Smart transmitter too? So you don't require the transmitter as both products are already SunSpec compliant, correct?
Absolutely correct, and want to emphasize on that. Please don't use the external transmitter. The benefit of having the SunSpec transmitter integrated in the inverter is that any other safety features, say like AFCI detection, is not fooled by a power line communication signal being generated by an external transmitter. So having the internal transmitter coordinated under the same microprocessor control as any other safety features is critical. So please only use the internal transmitter in the CORE1 and never the external. So yeah, great correct answer. Thank you. Great point of emphasis.
Great, I think we're good for now.
Awesome. Okay, well, let's dive on into the PEAK3, and it's a bit of a mindset change. While this is a very standard off-the-shelf string inverter from SMA, very much like the CORE1, this is in our utility scale portfolio with our Sunny Central inverters. And I really wish we hadn't used the name Sunny Mini Central in Europe, because that's really what this device is. This device is targeted for use cases, and you can kind of see back here, large scale distributed generation power plants. So that may be large community solar, it may be a giant utility, multi-megawatt utility scale field. The PEAK3 has found a lot of application in floating solar as well. But again, the large scale array, not building mounted, large scale ground mounted arrays where having many strings of exactly the same length and same orientation is not considered to be a challenge. There is only one DC input to each PEAK3 unit. So you have that single tracking channel, and we're aiming for very high conversion efficiency. So trading back off, we're discarding the design flexibility, and we're aiming in this unit for very high conversion efficiency. So there are 2 variants of the PEAK3 that have UL listing. One is a 125 kilowatt unit that outputs natively at 480 volts 3-phase. The 150 kilowatt model outputs at 600 volts 3-phase. So the power class locks in the AC service that the inverter ties to. So those 2 power classes, 125 kilowatt or 150 kilowatt, again, you have a single positive and negative DC input coming to the inverter. So very much like our central line, single tracking channel, aiming for very high conversion efficiency at high power levels. My understanding is that code may be different in Canada versus the US. In the US, the inverter itself, this is rated up to 1500 volts. There is not an allowance for anything over 1000 volts on a commercial rooftop in North America. These machines really do need to be working with arrays that are strung up to 1500 volts. So that is one kind of disqualifying factor for using on a rooftop down in the US. The other one is there is no AFCI built into each inverter. So that's a second disqualifying situation for rooftop applications. There is not a combiner box as part of the CORE1 PEAK3. SMA does not sell a UL listed combiner box for this inverter, but you will definitely need one for each and every PEAK3. My understanding for AFCI detection circuitry is there is a current limit for which they are functional, and the input current limit on the PEAK3 is way too high. So if the AFCI detection is needed, it would have to be occurring at the combiner box level. So again, some disqualifying, I think, factors for this not to be considered a rooftop device. So there may be other questions on that, but I just want to make that very clear. This is intended for large-scale distributed ground mount or perhaps floating solar mounts, but a very high efficiency device for large amounts of power and a very compact footprint. In this slide, we're showing kind of the same thing we did for the CORE1, the top part of the data sheet for the two variants, the power classes for the PEAK3. There is the open circuit voltage limit for all of these units, which is now 1500 volts DC. And there is a short circuit current limit, but as there is one input on the DC side, there is only one number here, and it is quite large, 325 amps. Of note, that is the short circuit current limit for the inverter. In operation, the inverter will draw a maximum of 180 amps from the array attached to it. And it can safely hold at that level if you have a nice DC to AC ratio for the inverter, and the array is capable of providing more power to the inverter than it can process. It can safely hold at this 180 amps, or what is commonly referred to as clipping, very, very safely, as long as the 1500 volts and 325 amp short circuit current limits are not exceeded. Very similar to the CORE1, on the data sheet, you see a maximum array power for each unit that you can go up to as long as the open circuit voltage and short circuit current limits are not exceeded. And the math is the same, 1.5 ratio for the PEAK3 like the CORE1. And the process is similar if you wish to exceed that. We would want you to do a design for the specific site you're considering, all of the correct design factors, run the design, and look at those peak load hours or full load hours. Let me fast forward through the presentation, the full load hours for that specific design. And we've just upped the limit for the PEAK3 to be 3,000 full load hours. So again, if you wish to exceed that datasheet 1.5 DC to AC ratio, that's what you would need to do, either with SMA's help or on your own. Document the design and show that the full load hours are under the limit for the devices. And we see that very commonly for both the CORE1 and the PEAK3, that people want to do that. So definitely you won't be the first if you want to go past that 1.5 ratio. Down here, I just want to comment as to my point about saying that these units really should be working with arrays that are strung out to 1500 volts. For the 150 kilowatt unit, that's an almost have to have. Again, the MPPT operating voltage range goes down to 855 and then all the way up to 1500. But if you try to work this inverter with an array that was limited to 1000 volts or less, I think you would have very poor behavior from that system. So these really should be considered 1500 volt array machines only. The PEAK3 has been, I think when we launched this, we expected high customer uptake, but I think we were even surprised. We expected, I think, low single-digit megawatts to be the kind of high end of plant size for utilizing the PEAK3. But our Northeast US channel sales manager, I believe he's in discussions with someone who is envisioning a 70 megawatt plant with the PEAK3 inverter. So probably a little higher system size than we expected, but it's been enthusiastically adopted. But we generally would suggest, even with the PEAK3, where you have smaller power conversion units, to have as many of those units as possible be centrally located. And the reason we would say that is that even the 150 kilowatt unit, the AC or output side voltage is 600 volts, where the DC input voltage side should be much higher. So having very long runs at the higher voltage, you will have lower line losses for transmitting the power. So generally, it's much better to have the DC conductors go a long distance versus the AC conductors. So having the combiner boxes out at the array, but not having the inverters out at the array, having them on a centralized location where the AC runs to a step-up transformer or the point of interconnection being as short as possible to minimize those losses. Any losses, if the inverter is outputting full power on the AC side, any line losses past the inverter cannot be overcome by the inverter. They are simply losses. But if you have line losses on the DC side, you can potentially size up the DC to AC ratio and compensate for those losses while still having the inverters outputting maximum power, maximum potential revenue. So again, another reason having the AC runs as short as possible is generally recommended. And a final, almost afterthought for many folks is, if the inverters are all very close to each other, the communications between them, even if it's forgotten in the design phase, is very easy to accommodate. If the inverters are spread throughout the PV array, and then it is kind of come to, oh, we're getting close to commissioning, we need monitoring, we didn't trench for the communications wires, it becomes very problematic. So that communications, hopefully it's not an afterthought, but it is, it's very easy to accommodate. So generally this centralized plant layout, even using more distributed power generation units, the centralized plant layout is almost always the SMA recommendation for utilizing the PEAK3. And you can see kind of the images we have. The installation for the PEAK3 allows for very close side-to-side clearance and pretty close back-to-back clearance. So quite often a rack is built where, if you have 8 125 kilowatt units, that's a megawatt of inverter capacity in a very small space. So having these racks, maybe they're covered if you're considering a very harsh climate, again, maybe in an enclosure, but fairly space efficient, high efficiency, and a fair bit of power handling capability. So we've had many customers enthusiastically adopt the PEAK3, but it is also very, very easy to understand. Really, the only choice you have is which power class do you want to pick. In stark contrast to our Sunny Central line, there are no other options to spec on the PEAK3 when you order it. If you're thinking about our Sunny Centrals, you will spend a lot of time with our project management going through the option codes for the Sunny Central, and only when that is fully ironed out can you then order the Sunny Central and you're in the production queue for the factory in Germany. The PEAK3 is a very easy to understand off-the-shelf device, very standard. So if you have these large megawatt plants, having maybe 1 or 2 units on site as spares, it is certainly very reasonable. You know exactly what you need for a spare. You don't have to worry about option codes. Waiting to the evening and having 2 folks swap out an inverter is a very straightforward way to bring one inverter back online, rather than necessarily diagnosing everything and getting a service tech to show up if that's required and rectify the situation. So I think, again, all of these are factors driving adoption of the PEAK3 to higher and higher plant size. And I think it's even exceeded SMA's expectation for this type of plant design. I didn't mention it, but both the PEAK3 line and the CORE1 line, if you go to their respective product pages on SMA-America.com, there are transformer requirement documents for both product lines. And the only thing I want to mention about that related to the PEAK3 is the transformer requirements for the PEAK3 are, I think, far more permissive, less restrictive than those for our Sunny Central line. So you very likely will be using a transformer with the PEAK3, but the specifications that are required, it may be easier to source those for a plant with the PEAK3 than the Sunny Central per se. But I will close. I know we're wrapping up on time, so I don't want to run over. In terms of standard warranty, the PEAK3 is in our utility scale portfolio, so the standard warranty for that is similar to our Sunny Centrals. It's a 5-year standard. The CORE1 starts at a 10-year. Both of those lines can be extended in 5-year blocks from the standard amount up to 20 years maximum. So it is possible to purchase that warranty extension at the time of purchase of the inverter, or really at any time through the factory warranty of the device. And while you can purchase that directly from SMA, our distributors will have much better pricing on extended warranties. So I would strongly suggest you talk to BayWa about the extended warranties if you are interested. You'll get better deal from them. And with that, I think I am ready to take questions. And if we have time, I will speak on the online service center, but I don't want to take Q&A time for that.
Just see one question. I have 2 SMA 50 kilowatt inverters. Do I need overcurrent protection for each inverter, or can I use one fuse disconnect instead?
Generally, for systems in the US, there is generally expected to be a separate disconnect and overcurrent protection for each inverter. So I'm not certain what the allowances for not doing that are, but generally you're going to have a disconnect for each inverter. There may be then a massive fuse disconnect for the whole PV system when it's tying into the point of interconnection with building service. But my very limited understanding, as you probably will be requiring a disconnect for each inverter. And that may change based on if it's a ground mount system versus a building mount. But
I don't see any other questions at the moment.
okay, so if I can, I will take 2 minutes. The online service center for SMA, anybody who's actually working supporting SMA inverters, if you're not familiar with the online service center, I would ask you to become familiar with it. The my.sma-service.com website is another way to interact with the SMA service line. There is phone support and there is email support. Those have not gone away, but the online service center is an addition to that. If you create an account on the online service center, you can create service tickets through this portal without needing to be on the phone with anyone or sending an email to service. Once you've created that ticket, you can attach documentation to it, say pictures, screenshots. If you've been down this road before and you know you need to include pictures of your multimeter to diagnose this issue, you can include those immediately when you create the service ticket. And so then when an SMA service tech logs onto your case, they'll see that documentation and potentially speed up the resolution of your case. Also, on the online service center, whether or not you have an account, there is a search bar at the very top, and it provides, I think, more thorough explanation, particularly of SMA error codes, than our user manuals do. So again, it can be a great resource for service support information, as well as another avenue for interacting with SMA service line. So I'd strongly recommend understanding the online service center. So with that, I will close the presentation and say thank you, everybody. If there are no other questions, I'd be happy to address any if there are, but I believe I'd ask two folks maybe to follow up via email with me. So my email is Michael, MICHAEL.Mahon, MAHON, at SMA-America.com. I don't know if I should just type that into the chat window or if.
And I guess we do have another question here. These models have been around for a while. Anything new coming out for North America?
Ooh, yes, I like this. Somebody's going to get me in trouble with my boss. There is a trade show in Anaheim, California. I think it's the 19th to the 22nd of September. We will be introducing a smaller variant of our Tripower line, the Sunny Tripower X. So there will be a new addition to our commercial portfolio. It will not be immediately available, but it should be available shortly after the show. So we will definitely be talking about that quite a bit. And for the PEAK3 line, there are some updates coming. We have two slightly higher power classes on the roadmap that I'm sure we will be discussing at that show, RE+, formerly known as SPI. And there's an even more exciting development on the PEAK3 front coming after that. I don't think I'll get us in trouble by discussing it. It is going to be an IEEE 1547 listed device with variable AC voltage. So this, I think, will be very, very popular with our repowering division. If you're coming to replace, say, a very, very old Sunny Central from SMA, those inverters' AC output voltage generally was chosen to maximize the device efficiency, and is so usually not a very standard AC voltage. The PEAK3 with that variable AC output voltage will allow it to be set to whatever device it may be replacing without having to worry potentially about transformer swap outs. So as a new product, I don't know that that will be especially exciting to the audience, but for those who deal with repowering, I do believe that will be a very, very interesting development in the PEAK3 line. And I think that's all I should say. I'll get in real trouble if I say more.
Great. And someone's asked about supply issues. So there's still constraints, but BayWa has put in a significant order. We're waiting on confirmation when that comes in, but we should see more product towards the end of the year. But just please reach out to your account rep for additional details. But we have significant orders in place, and your individual reps can confirm when product is available. So thank you very much, Michael. Really appreciate your time. Great presentation. Indeed. Appreciate it. For everyone, thank you for taking time out of your day to be with us. Just a couple of notes. If you haven't signed up for our web shop, please do. You can find all the specs, pricing, inventory, install manuals for SMA. It's all sitting on there, as well as our other products. This was recorded. We'll share it via our YouTube channel, so please sign up for that if you haven't yet. It'll also come out in the monthly newsletter. If you have more questions, please reach out to your dedicated sales reps. They'll be happy to help you out. We will be at SPI as well SMA, so if folks are traveling from Canada, you know, we'd love to see you. So please reach out to your BayWa rep or myself personally. We'd love to see you down there. We do have 4 warehouses across Canada, so you can see where the SMA product is at. So once again, thank you, everybody. Thank you, SMA, and have a happy hump day. Take care.
Awesome. Thanks again, Matthew. Thanks for having us. Bye-bye.